Welcome to another tutorial in MATLAB. In this tutorial series, we are looking into the concept related to Simulink, and in this particular video, we will be looking into the concept related to 1D lookup table, and we will be applying it to a real scenario. So suppose we have a battery or any device which is we want to operate in exactly in a physical or real scenario. You will have some limits to the device. So suppose you want to operate a battery that is present in some battery pack. Then in that case, like suppose you want to operate the battery, you want to determine like what should be the optimum limit of current that I want to find for this particular battery, like based on different temperature. Here the temperature could be one input that you will be giving inside the lookup table. So we will have a lookup table which will tell like what is the current limit. The environmental temperature will be taken into consideration in this case. So why environmental temperature is taken into consideration? If the temperature of the environment is more and you are applying a very high current inside the battery, then in that case the battery will get heat up and you will damage the battery with this high amount of current. So what you can do over here, you will have some limits of current based on temperature, like you will have some temperatures here, like and you will have some limits. So suppose this is the current limit side and this is the temperature side. So based on the temperatures you will have different limits for the battery, and that way you can optimize the temperature and current, like based on temperature you will be optimizing the current, and this could be applied for both charging and discharging, or you can have a separate lookup table for discharging and you can have a separate lookup table for charging. So yeah, let's jump into the implementation for this same. So for this we will be using the MATLAB model. So here is the lookup table which is related to the current and the temperature. So if we want to see it in an Excel sheet, so yeah, let's see it, which is temperature current table. So if I want to open it outside MATLAB, then here you can see. So here you can see we have the temperature and also the current limits. So basically if the temperature is -40, then you will be having a current limit of 0.1. Suppose if the temperature is 0, then you will have a current limit of 5 amps. Maybe if temperature is 60, then you will have again the current limit of 5 amps. And here the limits are gradually increasing and decreasing based on the temperature. So that is how we are optimizing it. So using this table, we will be basically implementing this table inside the lookup table, and we will see different components that are being used in the lookup table and how we will set different parameters for the lookup table. So now let's start a Simulink model. So for this we will go to the model part, and the Simulink will start. We need to give some name. So we are giving temperature current limit model. Yeah, once it is done, we will just double click and open the model, which will be definitely a blank model, and here we need to incorporate the lookup table. So let's find the lookup table in the Simulink library. So if you search for lookup table, you will have a lookup table like this, which you can drag and drop, which is called 1D lookup table. And over here, if you want to see like the points, okay, so the points the table data, this is the y-axis, which is the output, and the breakpoint, that is the x-axis. So whatever the value that you will give here in this field, that will be the value for x, and whatever the value that you will give here, it will be for the value of y. And here also the algorithm section that we will also see later on. Okay, now let's look into the breakpoint. So we have the breakpoints with us, and we need to fill that breakpoint. So we need to take the breakpoint that we have from the Excel sheet, and we will take all these points with us to fill it up inside the table. So now we will be filling up the table with the data. So manually we need to type it. You can also have it like inside a MATLAB variable and store it in a .mat file. But yeah, here basically we will be typing it manually. So the thing that I'm currently typing is the current limits that we have, and based on this current limit we will have the value for the temperature, which is varying from -40 to 60, and this current limit is varying from 0.1 to 20. Yeah, so based on this we will update the points. So now all the points are updated. Now let's so the lookup table is now updated. Now we will be feeding off the data inside the lookup table. We need to give the input and we can see the output in the form of display. We will give the corresponding value and we will see like whether we are getting the same output or not. So here in this case we have given 11, so 11 will be more close to 10, so the output should be more close to 10, right? It is 10.5, and as you can see over here the value, if we change further like make 12 or 15, then in that case you will get the value that is higher than 10 but lower than 15, as you see for the current. So now suppose if I'm like giving a variation of values between the maximum and minimum range of the temperature, so temperature is changing with that. So yeah, so let's do that. And yeah, so I need to set the amplitude. So for this I will be setting the amplitude to be 30, and the frequency is set to 0.01. Now we will connect this block with the lookup table. We will put a scope will give you the output variation over time. So we will connect both the input and the output, and we will see like how the things appearing based on our input with respect to the output. We will give a defined name to the signals. Yeah, and we simulate it. So as you can see, if I double click on the scope, then I'm getting this output. I'm just changing the layout. So you can go to the layout and change the view type, and you will be able to see the limits as based on temperature. As it is changing, the current is also changing. Yeah, and here what I'm doing, I'm setting open start at simulation. So this will start the simulation, and also I'm setting the legends so that I can see which signal is which in the graph. Now the simulation time I need to increase. So in this case like I was having 10 seconds of the simulation, but now I will set to a higher value so that while the temperature is changing, I can see how the output is changing over time. So again, maybe I need to further increase the simulation time. So yeah, we can increase the simulation time to some higher value. Now if we play, then you will get this variation, like as the temperature is changing, the current limit is also changing. Over here, as you can see, I'm changing the temperature, which is the temperature is getting changed. Gradually it is changing, and you can see there is a variation in the current, and the current is also adapting based on the lookup table, and that way you will be updating the current limits within the device, and you can protect your battery from being damaged at different temperatures. So such things you can implement. This is a real example. It is not like you can apply it only to battery. You can apply it to determine what is the possible maximum current rating you can determine for any device, and based on a lookup table you can do that, and you can implement the same, and you can make your limit calculation more easier, because here we are just giving some input, and through the table we are calculating the output. Yeah, so this is all about the one-dimensional lookup table, where we did see that we are applying one input and we are getting one output, and here in this case we are having the temperature of the environment is one input, and the limit current limit is the one output. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. This will help us to improve your experience of learning MATLAB in this channel. Have a great day ahead. Thank you.